During the fabrication and installation of HVAC ducting, we use different fittings like transition piece, elbow, Y branch, and offset. Also, during external static pressure calculation for HVAC ducting, the duct fitting equivalent length and duct fitting loss coefficient depends on its fabrication process. There are certain rules that need to be followed during the fabrication of duct fittings. In this tutorial, we will study them one by one. I, Engineer Nasir, welcome you to our channel NC Engineering and Technology. Friends, if you are new to our channel or still you have not subscribed it, please subscribe to our channel so that we can make more studies and bring more videos for you. We will start our study from the straight duct. When we design or fabricate HVAC ducting for a project, we always try to have the minimum pressure loss inside it so that we can have the smaller fan size and lesser power consumption. The friction loss inside a straight duct depends on its shape, and there is one general rule: less is the perimeter area ratio, the lesser will be the friction loss inside it. The perimeter area ratio is minimum for the round duct. So at a given velocity, round duct have the lowest static pressure drop per linear foot for any shape of duct. Now we have understood from this study that we have the minimum pressure loss inside the round duct, but whenever we go at any project, we found that most of the duct installed is rectangular. Why? It is because round duct unfortunately requires larger height clearance when compared to the rectangular duct. If we have the same cross-sectional area for a round duct and rectangular duct, the height required for the rectangular is lesser than the round duct, and normally we are short of space above the false ceiling, so we prefer to install the rectangular duct. You can see most of the shopping mall, they don't have the false ceiling, and we always use the round duct there, and we paint it to make it decorative. For a rectangular duct, perimeter area ratio increases with increase in aspect ratio. What is aspect ratio? Aspect ratio is the longest dimension divided by the shortest dimension. You can see in this picture we have a duct. Its longest dimension is 8 feet and shortest dimension is 2 feet. So the aspect ratio for this duct will be 4:1. As the aspect ratio of a duct increases, then the friction loss inside the duct also increases. In a rectangular duct, large aspect ratio may cause. Thumb rule for the aspect ratio. Generally, duct aspect ratio should be limited to no more than 4:1. Duct reduction. When we make a branch or take off from the main duct, as the CFM decreases, we need to reduce the duct size. It is recommended to keep the same duct size until a reduction of 2 inch is needed. In this picture you can see we have a duct. We make a branch, then after the branch we check the duct size and we found we have a reduction only 1 inch. The original size is 16 by 14 inch, and after one branch we need the size 16 by 13 inch. So we keep the same size, we did not make any reduction. After the second branch again we check the duct size and we found the duct reduction in the duct size is 2 inch. So we change the duct size from 16 by 14 inch to 16 by 12 inch. In the same way, in this duct, when we make the one duct take off, again we check and we found then we need to reduce the duct size only by 1 inch. So we keep the duct size same. And after 2 branch again when we check the size, we found that we need to make a reduction of 2 inch. Then we make the duct size of 16 by 10 inch. So it is recommended that all duct sizes should be in 2 inch increment, preferably in one direction only. The recommended minimum duct size is 8 inch by 10 inch. Number 1. Use of duct transformations or transition piece to change the shape of a duct while the cross-sectional area remains constant, then a slope of 1 to 4 should not be exceeded. In this picture you can see a duct having size 200 by 500. When we change it to another size 500 by 200, then the shape of the duct is changed but the cross-sectional area remains the constant. In this picture you can see we have a transition piece with the cross-sectional area remain constant. When we are decreasing the size of 1 inch, then we need to fabricate this piece in a length of minimum 4 inch. Number 2, duct transformations or transition piece to increase the duct area. In this picture you can see we have a duct having the original size 500 by 200. We need to change this duct to 500 by 400. In this case we are increasing the cross-sectional area of the duct. When the duct area is increased, the slope of transformation is not to exceed 1 to 7. You can see in this picture, if we are increasing the duct dimension 1 inch, then we need to fabricate this transition piece in a length of minimum 7 inch. Number 3, duct transformations or transition piece used to decrease the duct area. In this picture you can see we have a duct having the original size 500 by 400 and we are changing it to another size of 500 by 200. In this case we have decreased the cross-sectional area of the duct. When the duct area is decreased, the recommended slope of transformation is 1 to 7 and it can be extended up to maximum 1 to 4. If we need to fabricate a transition piece and we are decreasing the size by 1 inch, it is better we fabricate this transition piece in a length of 7 inch. If it is not possible, we cannot fabricate this piece in a length of less than 4 inch. When we are using duct fitting as elbow are of 3 types. Number 1, full radius elbow. Number 2, short radius vane elbow. And number 3, vane square elbow. If we have the round duct, then again we have 3 types of round duct elbow. Number 1, smooth elbow. Number 2, 2-piece elbow. Number 3, 5-piece elbow. There are some terms that is used in the elbow. These are number 1, throat radius. Number 2, heel radius. And number 3 is center line radius. What is heel radius, center line radius and throat radius? You can see in this picture, the radius of the inner circle of the elbow is called throat radius and the radius of the outer circle of the elbow is called heel radius and the radius of the center line of elbow is called center line radius. Full radius elbow are constructed with a throat radius equal to 3-4 times the duct dimension in the direction of turn. It has an RD ratio equal to 1.25 and this is considered to be an optimum ratio. You can see in this picture the throat radius value is 3-4 times the dimension of the duct in the direction of turn. Short radius vane elbow are constructed with a throat radius equal to 1/10 of the duct dimension D in the direction of turn. It has different R by D ratio. The vane square elbow is expensive to construct and usually has a higher pressure drop than vane short radius elbow and the standard elbow. For the round duct, smooth elbow are recommended for round and spiral duct. RD ratio of 1.5 is standard for all elbows used with round or spiral duct. A 3-piece elbow has the same RD ratio as smooth elbow but has the highest pressure drop of either the smooth or 5-piece elbow. This elbow is second in construction cost and should be used when the smooth elbow are unavailable. The 5-piece elbow has the highest first cost of all the three types. It is used only when it is necessary to reduce the pressure drop below that of the 3-piece elbow and when the smooth elbow are not available. When we are using a Y fitting to make a takeoff or the branch from the main duct, the elbow portion for the takeoff or the branch should be considered as full radius elbow, and the inner radius will be 3-4 times the branch or takeoff duct dimension. The remaining straight portion should have a slope of 1 inch in 7 inch, or in angle you can say 30-degree angle. For the fabrication of offset, we can follow 3 types. Number 1, in this case we have to straight duct. Offset fitting we can fabricate in 3 types. Number 1, you can have to straight duct and can join by offset. In this case you cannot exceed the angle for the offset more than 15 degree. Number 2, you can cut the straight duct in the angle you need to join two duct at different levels. In this case you can have the maximum angle 60 degree. Number 3, you can fabricate the offset with round, having the throat radius minimum 6 inch or 150 mm. For the fabrication of standard bell mouth, you can follow this process. You need to keep the same duct size up to minimum 1 inch. After this, for the fabrication of the curve, you need to follow this radius r equal to duct size is divided by 5, and the total length of the bell mouth should be minimum 3 inch. For simple takeoff from the duct, you need to make a slope of 45 degree in the direction from where the air is coming, and the length of this takeoff will be equal to L is equal to 1 by 4 times the width of the duct, and this value should be minimum 102 millimeter. Now we will see how to calculate the vane for a short radius vane elbow. Assuming we have an elbow having the throat radius of 2 inch and the heel radius of 20 inch. You can see this chart from the SMACNA. This line is showing the throat radius and the lower line is showing the heel radius. We will locate the value for the throat radius 2 inch on this line and the heel radius 20 inch on this line, and we will join these 2 points by a straight line. If we are going to use 2 vanes, then we will select the value on the line of number 1 of 2 and number 2 of 2, and you can see this line is cutting number 1 of 2 here, and when we will trace it up we found that it is cutting on 4.5 inch. So the radius for the first vane will be equal to 4.5 inch. Then we will see for the second point. At second point it is cutting here, and when we will join this line we will go to straight, then we will find the radius for the second vane will be 9.25 inch.